So this is Higher Notes, Unit 1, Section 2 on forces, Part 1. And in Part 1 we'll deal with Newton's first law and we'll introduce the idea of Newton's second law. Right. Okay, so let's deal with Newton's first law first. I will often shorten it to N1 for Newton 1. Well, this is a law that you need to effectively memorize. And here it is, I'm sure you know it. A body will continue to move with uniform speed in a straight line unless acted upon by an unbalanced force. Put a box around that, so it's so important. A body will continue to move with uniform speed in a straight line unless acted upon by an unbalanced force. What we're basically saying there is that if the unbalanced force is 0, then, so an unbalanced force of 0 means either 0 forces or balanced forces, then v, the velocity itself, will either be 0 or it will be constant. So that's like a kind of shorthand way of expressing Newton's first law. But if you're ever asked to state it, you should give it in full, giving the text that's in that box. Okay? So 0 forces on a body or 0 unbalanced forces on a body mean the body can only be in 2 states. It's either at rest or it's moving with a constant velocity. Constant velocity, of course, means constant speed or uniform speed in a straight line. Well, that is learning outcome number 1. Learning outcome number 2, so note number 2, is Newton's second law. Right, well, Newton's second law is best defined as an equation, and one you're all familiar with, I'm sure. So you state the equation, F unbalanced equals ma, but you need to say where Fun equals the unbalanced force on a body in newtons. You must specify the unit. M is the mass of the body, and that must be in kilograms for the law to hold. And A is the acceleration of the body in meters seconds to the minus 2. Okay, so if you write all of that down and you refer to the body, then you have stated Newton's second law. We'll do an example on that in a minute. Number 3 is the definition of the Newton. Well, the definition of the Newton comes straight from the statement of Newton's second law. It's quite simple. A Newton is that unbalanced force that causes a body of mass 1 kilogram to accelerate at 1 meter seconds to the minus 2. And Newton is that unbalanced force that causes a body of mass 1 kilogram to accelerate at 1 meter second to the minus 2. Okay. Let's do an example. Of Newton's second law. So let's imagine we have a car. There we go. And we have, let's say, an engine force which we will make 2,000 newtons, and that's driving the car along to the right. But opposing that motion, we have various frictional forces due to air resistance and just friction in the whole car's moving parts, so we'll just call it friction, and we'll say that that's 400 newtons. Friction, of course, always opposes motion. Let's imagine that the car has a mass of 1,000 kilograms, and the question then is, what is the acceleration of the car? Okay, so fairly straightforward, but it's a good example to show you how you approach these problems, because there's a sort of standard way of doing them. Okay, so stage 1 in the solution is basically to find the unbalanced force. So I'm on the actual solution now. Okay. Right, well, we find the unbalanced force by simply taking all the forces acting to the right and all the forces acting to the left, decide which ones are bigger, Now clearly the engine force is 2,000 newtons, that's bigger than the friction. So the car is going to be moving to the right. So we can tell immediately the motion is to the right. So we take the bigger of the forces, that's the 2,000 newtons, so that's going to be the engine force. And we're going to be taking away from that the friction. So you can see that we've set up an equation for the unbalanced force. Now in problems like this, you don't generally need to apply the sign convention. You can if you want, but it's generally not that required because the body's usually only moving in one direction. So the engine force is always to the right in this case, and the friction is always to the left, so it's kind of obvious where the car is going. So I'm not going to bother with the sign convention for this because it's just not needed. So we then have 2,000 newtons to the right, take away 400 to the left. Well, that's 1,600 newtons. Now, just because I'm not using the sign convention, it doesn't mean directions aren't important. All I do in this case is I use my knowledge of the context to decide on the direction. So it's pretty obvious that it's the unbalanced forces to the right. So I just put to the right. I know it's to the right because the diagram given to me in the question tells me that it's to the right. Right, so that's stage one. We've actually sorted out the unbalanced force. And in many, many problems you do, you will need to sort out the unbalanced force first, usually drawing a free body diagram, which is effectively what I've got there, showing all the forces acting on the body. And then stage two, usually, is to then find the acceleration. So use F equals me to find the acceleration. Okay. So we can now write our expression of Newton's second law. We now know the unbalanced force is 1,600. The mass of the car is 1,000. And the acceleration is the only unknown. So we rearrange. Okay, I can see there's going to be some cancelling going on there. So it's really like 16 over 10. So that's like 1.6 meters seconds minus 2. Remember, acceleration is a vector quantity, so we do need to specify a direction. Well, if the unbalanced force is to the right, then the acceleration is also to the right. And there is how we use Newton's second law.